Hello, everyone. Welcome to Build 2017, and this is the session about React, React Native, and a bunch of React-related stuff. Before we begin, how many of you here were for the same session yesterday? Not everyone. OK. So yesterday, I did the same session, but it was done by me, not by Adam. The session yesterday was basically a quick introduction about React and React Native. But today, it's even more special because we have Adam Wolf, who's the director of engineering from Facebook. At Facebook, Adam basically manages the team that runs React.js, React Native, and GraphQL. How many of you here have heard about or used React.js? Almost everyone. That's good. How many of you have done any React Native related stuff? Not many. OK. And GraphQL? One, and that's Joe. Joe works at Facebook. So. Awesome. So the reason, so Adam is basically going to be talking to you guys about what Facebook does with React and React.js and React Native and all of that. I think the interesting part in his discussion was going to be about the philosophy of React.js, and that's something. So I kind of took a sneak peek at his slides, and they were interesting because it kind of explains the whole idea behind React.js and why it was developed. I know we're not supposed to start for another 2 minutes, but given the good quality of content that we have, I'm assuming that given that you guys are already here, let's get started. So please welcome Adam Wolf from Facebook. He's the director of engineering, and there you go.
Thanks, Ram. Hi, thanks for coming. Yeah, so as Ram said, I'm Adam Wolf. I work at Facebook. I'm an engineering director there, and I'm responsible for our front-end infrastructure team. And this team works on a bunch of technologies that are aimed to make front-end development easier and faster. And I want to give you a tour of what we're working on, tell you about kind of some of the solutions we have, some of the problems we still face. So by far, the most well-known project that comes from this team is React. And that's probably why a lot of you are here. I saw a lot of hands go up when we asked if you've used React. I want to go back a little bit, though, and talk about why React is the way it is, and also why I think it's been so popular and been adopted so widely. And to tell that story, I kind of have to go back a little bit. So, 4 or 5 years ago, when you started to build a new user interface, the advice you got about how to do that was to implement this pattern that we call MVC, Model View Controller. People here are familiar with MVC. OK. Lots of people are. Great. So, and I'm trolling a little bit here because I'm showing the model, view, and controller as each bidirectionally coupled, which, different architecture diagrams show different things here. But my experience is that it's actually pretty hard to keep these things from being deeply intertwined because they're each stateful objects, and they each have a different slice of responsibility for the user interface. But the real problem with MVC is actually not even this pattern. The problem comes when you try to compose MVC. So I've written this piece of front-end logic that contains a view, and I want to go reuse that view in another context. So I take my view and I embed it in another view. And what I quickly realize is that that's not good enough. Not only do I need to couple the views hierarchically like that, but I also need to couple my model that, the little correspondence of the model and view need to be embedded in a larger correspondence. And then it's not long before my controllers are embedding controllers as well. And if you've worked on a really big user interface, you know that it actually gets really hard to tell what's going to happen when a given change percolates through the system. And this architecture just kind of fundamentally doesn't scale. And React came along, and I think it really fixed that. Instead of saying we're going to divide up the responsibilities for user interface among a bunch of different stateful components, we're going to straighten it out and say the user interface is best thought of as a function, which turns the abstract data of your semantic application data into a data hierarchy that represents your view. And thinking of it as this pure transformation actually has a lot of benefits. It makes it easier to write these components, and it makes it much easier to compose them. And I want to illustrate this with a little bit of code. So this is the React API, and I know a lot of you have seen this before, but bear with me because I just want to make some points about how the React API works and why I think it's so effective. It's a declarative API. So what I'm going to show you is really this one function. It's called render, and that's like the heart of every React component. So I implement a class which extends the core React component class. I override the render function, which is kind of abstract in React. And this is where I get to do what my component does. So in this case, I want to show some red text on the screen. Obviously a trivial component, but hopefully you'll get the point for the purposes of illustration. I'm going to grab some text from a free function we'll just call getText for the moment. And this is an illustration of why React is kind of cool. When you first start using React, it integrates really well with the rest of your JavaScript because it's very unopinionated about where your data comes from. You can just kind of, as long as you can call a JavaScript function, you can use React. That's another benefit of this functional style. I'm also going to inline define a style, which is this object. React uses CSS. React Native also uses CSS, so it's got this very familiar API. And I'm going to make this is a JavaScript object that just has a key background color and a value, the string red. Then I'm going to return, and this is the declarative part where I'm going to return a data structure from render that represents the UI. So you can see we're taking data that comes from elsewhere in the app and some that's defined locally and spitting out this declarative data structure. What we're not saying is as getText returns different values, how this thing should update. We don't need to do that. We just need to define this render function. So I use this primitive called text. I set its style. The braces interpolate that object. So instead of the literal myStyle, it's the value held by myStyle. And then similarly, I can kind of splat my text out inside this markup and return it. And last thing I'll point out is that React uses this JSX style where it kind of looks like I'm embedding a template inside my function. It looks funny at first. It actually works really well. And the reason why we use this syntax is really just sugar for creating a data structure. But because the emphasis of React is so much about composability, this really helps with composability. It makes it very readable and very familiar. Now, I'm going to fix this up a little bit to componentize it a little more, and I'm going to make a couple changes here. So instead of just grabbing my text from anywhere, I'm going to now pass my text in. And this is called prop in React. And React props, if React is a functional approach to UI, props are the argument to your function. So in the same way that the primitive text has a style attribute, now I'm defining a prop for red text, which is its text attribute. And I'm saying that its default is an empty string, but obviously that can be passed in. And then all I have to need to change in my render function is to spit out the props that get passed in to this component. And now I can show you how we use that. So now I'm going to build a warning class. I'm going to start composing this. And again, we'll use these default props. Now, this time, warning has more semantic meaning. So we can say, if we don't know what happened, we'll just say something went wrong. I've seen that error message before. When I return from render, now I'm going to, similarly, in this case, instead of just composing a style, I want to compose some behavior. So I've got a click handler that does something when you click the warning. Who knows? And now I can pass that in as the click handler for this view. And now I'm going to use my red text component, passing in the warning that this component received from above. And you can kind of see how we start to be able to stack these components. And the cool thing is, I don't need to know what red text is or how it works. Maybe we want to log every time red text is shown to the user. I don't need to care about that. So this can be used for things that are not as trivial as styling, although styling isn't trivial. Actually, if you work on the front end, you know that styling, you spend a lot of time on that. And so, a big part of React is, again, moving away from this idea that the view is somehow simple or, the easy part of building the app. It's actually really important, and we spend a lot of time on that as front-end engineers. So this is the API for React, and it's declarative, right? And that's where the power of React comes from. And I'm going to hit this word over and over again. Declarative interfaces for building user interfaces. That's what our group does. And that has unique power for developers because it aids composability, and it also has unique value to the infrastructure engineers who maintain this stuff. And I'll talk more about that in a second. But first, I kind of want to tell you the story of React and what happened with it, because we were using React internally at Facebook, and we open sourced it. And at first, people started using React in the context of their existing app. And they really liked it. It was pretty easy to use. But then people say, hey, we really like this. We're going to build a new app. We don't already have a data source. How should we build it? What architecture should we use? And at that point, we sort of gave this talk and produced like a white paper kind of saying, like, we have this architecture idea that we call Flux. And we talked about it. And I don't have time to present Flux in detail, but the idea here is to try to straighten out the way data flows through your application. So rather than having this like web of stateful objects that are sending messages to one another, instead we have this idea of this thing we call a dispatcher, which is a single event emitter that all of the state change in your app passes through. That's the basic idea of Flux. And then we have a store which accumulates those changes and is able to reflect them into the view. Now, we gave this talk, we presented this stuff, and people got it, which was great, but we didn't provide any kind of implementation for Flux. And that turns out to have been a mistake. We won't do that again, not because we didn't get a high-quality implementation of Flux. It's because we got like 20 high-quality implementations of Flux that were all slightly different. And just preparing for this talk, looking at the latest here, just to name a few, there's Flumux, Fluxible, DeLorean, Flux, Fluxy. The list goes on and on. So, and really what we intended was for Flux to just be like a way to think about your app, not necessarily a framework. But it turns out that Flux is good for small things, but once you start scaling, it's not opinionated enough to really force you into the right patterns. And that's when Redux came along. And I see Redux as the real successor to Flux. It formalizes a lot of the ideas in Flux, and specifically it takes that store that you saw in the Flux architecture diagram and turns it into a much better, more carefully specified functional accumulator. And it has a high quality, high performance implementation of that idea. So a lot of people use Redux. It's really powerful. It's great for client-side data management. And it's a solution I point people to. People say it's too heavyweight. Sure. If it's too heavyweight, use something like Flux. But if you're building a big app, you need something like this to kind of keep it all straight. But neither Flux nor Redux actually solves the bigger problem that you have with client-side data management, which is not necessarily what happens once you get it on the client. It's how you get it there in the first place, especially if you're dealing with a mobile app where you have, invoking the radio is expensive for battery, you have high latency, intermittent connection. And so I don't need to come to Microsoft and tell people about the value of having a structured way to talk to your server. This is my little SOAP joke. I'm old enough to remember the bad old days of programming SOAP on the server. And actually, this technology that we developed at Facebook borrows a lot from SOAP. In terms of the idea of having strongly typed, introspectable boundaries at the edge of the server. It's a lot simpler than SOAP ever was, and it's designed for mobile. And again, I really don't have the time to go through exactly how GraphQL works, but we have a lot of documentation for it. It's open source. There's a ton of implementations of it, and I recommend you take a look. The point I want to make here is that GraphQL is a declarative API, and unlike SOAP, it's not generalized RPC. It's really structured around data fetching. What we want the developer to do is to say what data that they're trying to fetch from the server without saying how to fetch it. We want to defer that decision to the infrastructure so that we can make good choices about that. And especially as we roll our architecture forward, we don't want to get stuck with a lot of imperative code that specifically invokes specific network things or works around bugs in a specific network implementation. In this case, you can see the query language for GraphQL. Think of it like JSON with the values removed. We just write the left side of a JSON data structure, and the server is going to return JSON data to us. So in this case, we have a named query, which fetches me, and then we get these fields off of the data. And GraphQL is really optimized for mobile in the sense that you ask for exactly the data that you want, and you get back exactly the data that you want. So, for this first part of the presentation, I've tried to emphasize the value that these technologies have for developers. By making them declarative, they are composable. And GraphQL has a bunch of really neat features for composability. We have these GraphQL fragments, so you can embed little snippets of GraphQL in others. And again, you can build these really discrete components that compose really nicely. But if these technologies were just great for ease of use, I don't think they'd be that popular. I wouldn't be standing right here. And the reason is that performance and speed really matter, especially in the work that we do at Facebook. And to illustrate this, I pulled up this quote from a long time ago. This was even before I worked at Facebook. Google published this really influential paper called Speed Matters. And they did this test where they artificially slowed down search results, and they showed a negative correlation between engagement and speed. And if you work on a consumer-facing product, you just know this is true. You deal with this every single day. I see this all the time at Facebook, where by improving performance, we can improve user experience and therefore engagement. And React and GraphQL and the technologies around it have had a dramatic impact on the performance and efficiency of our software for the reasons I want to illustrate. When we make these interfaces declarative, we defer decisions about the implementation, and we can always make them better. You're not telling me how to render to the screen, you're telling me what to render to the screen. You're not telling me how to fetch the data that I need, you're telling me what data to go fetch. And that means that we're free to make improvements here. So for instance, in GraphQL, we can make a ton of improvements around build time. Even though it looks like you're composing GraphQL queries in a runtime, kind of view assembly, we can actually go back and extract a full query from your program at build time. And doing that saves us a ton of work at runtime. We don't, even just building up that big string is expensive on mobile, let alone shipping the bytes up to the server and interpreting them there. Once we do that, we can validate your query and make sure that you're asking for things that the server actually has, and we're not going to produce an error. And then finally, we can do even fancier stuff, like if you ask for you ask for the same data in 2 different places, we can merge that and avoid repeating ourselves in the data that comes back, save memory, save network. So that's just the example for GraphQL. For React, I think people are a little more familiar with the optimizations that are in React. And one of the early popularizers of React, who is Pete Hunt, who worked on the Instagram team, he sort of famously made this comparison between the Doom 3 rendering engine and the React Virtual DOM. And all game engines run in what's called immediate mode, which is conceptually they're repainting the screen on every frame. But that can be slow. And to optimize that, they use an intermediate representation of the scene so that they can separately optimize how that is actually drawn on the screen. But, and so a lot of people talk about this, and a lot of people think that this is really the essence of React. But I don't think it is. I actually think that kind of too much has been made of this. And for proof of that, I suggest you look no further than this React Fiber project that the React team has been working on for more than the last year. React Fiber is a complete rewrite of the internals of React. It's called Fiber because it implements concurrency in terms of JavaScript, basically with userland threads of execution that are defined as this Fiber data structure. I want to be clear, we haven't even taken advantage of this really successfully yet. We're just starting to experiment with this. We believe it will be really important and valuable. But that's actually not that important to me. What's important is that we were able to replace the internals of React without churning any of the code that calls it. We've already rolled out Fiber on Facebook.com, and we're starting to roll it out on Facebook's React Native projects. So we've shown that because React is declarative, we can change its implementation. And that comes with a whole host of other benefits. Fiber is completely flow typed. Unlike the old code base, people were really scared to go change anything in there because it was the first version. You can imagine it was daunting. We also, because we now know what React needs to do, over the releases of React, we've actually whittled down the API and made it smaller. And now we can make the engine smaller to match that. And then we've also added a bunch of convenience features that would have been really hard to add in the old version of React, such as returning a string from your render function or improving the error messages and warnings. So React Fiber is really exciting. I hope you're tracking this if you're a React user. It's already in the repo, and we're kind of gearing up for this with code mods and deprecations. So React has been really successful at Facebook. It's really helped us move faster at Facebook. We have hundreds of developers who write React every day, tens of thousands of React components checked into our source tree. And in our core apps, in Facebook, the app, we have hundreds of screens that are delivered using React Native. And I wish I could tell you, that's the end of the story. We're about done, and just everyone use React Native and go home. Unfortunately, we're not quite there yet. And a big part of the reason why why adoption of React Native isn't completely universal yet is because we pay an abstraction cost for JavaScript. React depends on JavaScript, and when I say JavaScript has performance issues, we can think of a few things that we pay penalties for in JavaScript. There's memory indirection in JavaScript. So to go find a field in an object, we have to hop through a few places in the heap. There's a bridging cost in JavaScript, right? JavaScript data, you can't just get at it from C++. You usually have to copy it, and you have lifecycle concerns. But by far, those things seem to be mitigatable to us, and we've had some success optimizing these areas. The hard part is init time for JavaScript. And in general, we're confronted with this situation where the user is moving through the application, hits a button, and now we want to start our React Native context and run a new program. And because of JavaScript's legacy from the web, JavaScript is generally designed to take source code, lex it, parse it, compile it, and run it all in that moment. And it's kind of amazing that all happens on your mobile device all the time. But it's really not good enough, especially when we're looking to replace an existing native screen with something written in React Native. So this is kind of where the cutting edge of React Native is right now at Facebook, and I just want to walk through a few mitigations that we've looked at. One thing is native prefetching. So in general, when we make that transition to a React Native screen, we know we're going to need some data to go for that screen. Now, I already told you that we can extract the GraphQL query at build time. Because we can do that, we can actually race the data fetching with the initialization of the JavaScript context. That's pretty effective. It works pretty well. We've seen some good results with this. It's fragile. It's complicated. It's you pay a penalty in terms of complexity for this solution, but it's something that we've had some success with. Another thing we can do is bytecode caching. So yeah, let's not do all that lexing and parsing. Let's just load our program that's already been compiled. And we're starting to see this happen in the runtimes. Facebook has sort of done some experiments with this. Again, it's promising. It's hard to keep that bytecode size down. There are other issues that crop up here. Another solution you may have seen from Facebook, it's this project called Prepack. This is this idea of an optimizing compiler. So if in your module you write x equals 2 plus 3, we'll change that to x equals 5 because we can do that at build time. And there's a surprising amount of JavaScript that actually kind of runs at initialization time that can be packed in this way. And in fact, if you declare X but never export it, we can just erase X. You don't even need it, right? So Prepack can have some dramatic results. It's also still really early, and it kind of gets in the way of over-the-air update, and again, it causes complexity. Last one is heap snapshot. I'm going to run out of time, so I better go quickly. This is the idea of instant on. So rather than say x equals 5, let's just restore a pointer to a heap where x equals 5. And you're starting to see this from V8. And I think the engines will need to do this, but this is exciting technology. But at Facebook, we really can't wait for this to happen. So while this is happening, we've been busy building native implementations, basically of React. And most recently, we open sourced this project we call Litho, which is an Android components framework that's very similar to React. You can see we have a lot of the things that I told you about from React here. Instead of a React component, we have a Litho component. Instead of a render function, we have a create layout function. But you can see the props are the same, and we still have this very declarative API for returning from render. And just to illustrate this point about the virtual DOM not being the end-all and be-all of React optimizations, the optimizations in Litho are pretty different from some of the optimizations in React. This is an illustration of fine-grained recycling, where we work around the allocator in the Android, both the garbage collector and the allocator, by doing very careful pooling of view elements as they come off screen and then reassembling them as they come on screen. We've had great results with Litho in our main apps. I really encourage you to take a look at this library. Last thing is, as we've been able to scale our user interface development, that's put pressure on our tools. So just as an example, JavaScript kind of leads the way in this kind of complexity. This is a graph of how many builds we do a day. We're talking about tens of thousands of builds of just our JavaScript every single day. And this, our tools slow down and bog down, and that's why the front-end infrastructure group also invests in tools. And one great example of this is this project called Yarn, which you may have seen, which is a dependency manager that works with NPM to make your builds faster, smaller, and more repeatable. I'm out of time, but thanks a lot. Yeah, I'll be over in the developer booth if you want to come and hang out. Thanks.
Hey, thanks, Adam. That was actually pretty amazing. And given that I use React and React Native every day, I think trying to understand the philosophy of why it was written is good. So as Adam said, Adam and I, both of us are going to be hanging out at the far end. If you have any questions, you can either catch us here or at the developer booth. Thank you.